Hey, the purpose of this video is to take the mole map, which you should have all filled out if you are watching this, and demonstrate how you use it to solve different kinds of mole problems. And so to start, we have 4 example problems to go over, and then you'll have a set of practice problems to try on your own. Again, you don't want to watch this until after you have completed the mole map because it might be a little confusing. So get your mole map next to you. And let's just get right into it here with checking out some of these problems. And I'm going to try to zoom in a little bit more here so we can see it a little bit better. Excuse me. Okay. So this document is, as always, posted. It's linked to the agenda if you want to have your own hard copy, or you can pause the video and take a moment and go through and write down the questions. So number 1, it says, what is the volume? Remember that I like to label problems as I go. And so what is the volume means that what I'm looking for is a number of liters. That's my unknown. And I have a container that contains 0.5 moles and it's neon, which we know is a gas, at negative 30 degrees Celsius and 1.5 atmospheres. So even though there's no mention of the word gas here, we know that it's not a solution, because in order for it to be a solution, if we look at our mole map, it would have to have some mention of the molarity. It has no mention of the molarity, but it does mention, sorry, my mole map is really zoomed in here. It does mention the pressure and the temperature that the gas is stored at. So we know that this is a gas, right? Plus, in theory, you would know that neon was a gas, but just in case you don't, those are your clues. It gives you a pressure and temperature. So the problem provides us with moles, right? So we are going to start here on our map. Sorry, now it's too zoomed in for my map. We're going to start here at the center on my map because I know the number of moles of the gas is going to be equal to to 243 Kelvin. And as we saw on our map, we're going to take the ideal gas law and solve for volume. So I'm going to do the number of moles times the constant times the temperature divided by the pressure. And I wrote that out just so that I could kind of remind myself. And now I'm going to go through and fill in all the missing variables. So 0.5 moles is where I start. My R, of course, is 0.08206. My temperature I just calculated is going to be 243 Kelvin. And then, of course, my pressure is 1.5 atmospheres. So then I'm just simply plugging and chugging, right? I'm taking those numbers and putting them right into my calculator. Remember that we multiply everything across the top, so 0.5 times 0.08206. Don't forget all those zeros, times 243, and then I divide by any number that's on the bottom, so divided by 1.5. And my answer is, rounding to 2 decimal places, 6.65. And because I solve for volume, we know that volume has a unit of liters. Simple, easy. There we go. All right. Next problem says how many moles. So I'm looking for a number of moles, which means on my map, I'm going to be going to the center. So my given is going to have to be one of the outer spokes. So let's figure out what it is. It says how many moles of NaCl have a mass of 300